In this practice problem, we'll determine the hybridization of all the atoms in these molecules. So even though generally as you practice, you'll be able to determine the hybridization right away by looking at the atom, in the beginning it's a good practice to find sort of like a formula that you can follow and determine the hybridization without making a mistake. And that formula is going to be determining the hybridization based on the steric number. So if we determine the steric number, based on that we can determine the hybridizations, knowing that if the steric number is 4, then it's sp3. If the steric number is 3, then we have sp2. And if the steric number is 2, then we have sp hybridization. So just a quick reminder. So steric number is the sum of the atoms. So it will be atoms plus the lone pairs around that atom that we're interested in. For example, if we're starting from this carbon and we want to determine the steric number, we're going to add all the atoms that are around it and also the lone pairs of electrons. So in this case we have 1, 2, 3 and 4, so 4 atoms around it, no lone pairs on the carbon, so then the steric number is 4. So if steric number is 4, then this is sp3 hybridization. On the next carbon, so we have 1, 2, 3, 4 again, so this again will be sp3 hybridization. Now if we're looking for example at this nitrogen, the first thing we need to do is make sure that we have the correct Lewis structure. If we don't have the correct Lewis structure, then we won't be able to see if we have lone pairs or not on that atom. So first of all, we need to remember that nitrogen is going to have a lone pair. And then after that, if we want to determine the steric number, we're going to add the atoms. So it's going to be 2 hydrogens and 1 carbon and 1 lone pair. So essentially the steric number for the nitrogen will be 3 atoms, so this will be again the 2 hydrogens here and the carbon and plus 1 lone pair. So remember that we're not talking about the number of the electrons, we're talking about number of the pairs. And in this case again this is 4, so this nitrogen again is going to be sp3. So let's go ahead and start this. So far we have all sp3 hybridizations. And now if we're looking at the next carbon, so this carbon has 1, 2, 3 atoms connected to it, no lone pairs of electrons. That means that this is going to be sp2. And same goes for this carbon, so it has 1, 2, and 3. So sp2 here again, because it doesn't have lone pairs of electrons. So at this point, we can actually see some patterns, and these patterns are going to be, if you're seeing any atom that has only single bonds, most often it's going to be sp3. If you see a double bond on the atom, for example, these 2 carbons, then most often it will be sp2. If there's a triple bond, for example on this carbon, it's going to be sp, which we can also see based on the steric number because it has 1 hydrogen and 1 carbon. So steric number is 2, then that's why this is sp hybridization. The method of determining the hybridization based on the steric number has almost no exceptions, very, very few. This one, even though there's not a lot of exceptions once you learn the pattern, but they do sometimes happen and you don't want to 100% rely on these. If you remember the exceptions and understand the principle how it works, it's okay, but for the beginning just go based on the steric number. As an example here, we're saying that double bonds usually represents sp2, but as a simple example, if you're looking at carbon dioxide, the carbon here is actually sp hybridized, and that we can explain by the steric number because it has 2 oxygens connected to it and no lone pairs, so that goes sp rather than sp2, which we could have seen from the double bonds. Another common example will be, for example, the carbocations that you will learn maybe later on in the semester. So for example, if we have this carbon with 3 bonds, it's going to have a positive charge. And this carbon only has single bonds, and visually it looks like it's going to be sp3 according to the patterns. However, you need to remember that carbocations are going to be sp2 hybridized, and the reason for it, so we're going to have the central carbon atom and we have the empty p orbital where we place the positive charge, and on this side when we have the carbon-carbon bonds, these are going to be the orbitals that are overlapping here. These are the sp2 orbitals of the carbon.